Thank you for tuning into the latest Arthur webinar. Today, I'll be speaking about LLMs and misinformation, a double-edged sword in the digital age. Before we begin, I will quickly introduce myself. My name is Cherie. I'm a senior machine learning engineer at Arthur. And at Arthur, we build an AI delivery engine that monitors, measures, and improves machine learning models and deliver better results. Since this talk is related to large language models, Arthur, we have launched Arthur Shield in the last year, which is the first first firewall designed for large language models. Arthur Bench, which is a robust way to evaluate LLMs, and Arthur Chat, a turnkey AI chat platform. So today we will be speaking about misinformation and large language model and how those two things inform each other. And we will be answering the following 5 questions. By at the end of this webinar, you will be able to leave with an understanding of what are the harms of misinformation, how misinformation was prevented before the advent of large language models and multimodal models, and the complex relationship between large language models and misinformation, which including the different ways LLMs can be utilized to both combat and create it. The potential failure modes in misinformation detection when using LLMs, and possible strategies and recommendations for resolving the issues of misinformation with the advent of LLMs going forward. At the end of this talk, there will be a good amount of time left for Q&A. Please use the Q&A function to submit your questions. Thank you. So first and foremost, we will need to set some baseline for definitions and taxonomy. What is misinformation? I'm sure many of you are not unfamiliar with this concept. There's actually a pretty fine categorization for misinformation. So here I am presenting a pretty official categorization from UNHCR. Misinformation is typically defined as false or inaccurate information, which is simply getting the facts wrong. Disinformation is another variant of misinformation with malicious intent, which is false information that's deliberately intended to mislead. For the sake of this talk, I will be using the umbrella term misinformation to capture both misinformation and disinformation and its finer variants, such as fabricated content, false context, manipulated content, imposter content, etc. So now I want to answer the question, how do LLMs contribute to misinformation? Since LLM has great generative capabilities and it's able to generate net new content with very little human input, it could be easily leveraged to generate misinformation. The advent of large language model has made a transformative impact. However, it does come with certain cost. LLMs such as ChatGPT can be exploited to generate misinformation, which causes serious concern for online safety and public trust. And here I'm presenting a taxonomy of how LLMs can generate misinformation. This is usually across the 5 axes, how LLM-generated misinformation is classified and analyzed. First and foremost, we have different types of misinformation related to fake news, rumors, conspiracy theory, clickbait, etc. And it could be in different knowledge domains such as healthcare, science, politics, finance, so on and so forth. The sources of misinformation could come from different form of generation. For example, the unintentional type, which is hallucination, and the more intentional, arbitrary and controlled generations. And the intents could be very different, both unintentional as a unwanted artifact of large language models or intentional generation. The errors can also vary from different degrees, from completely fabricated content to ambiguous content that leverage certain facets of truth. And we're going to go into more details how LLM-generated misinformation can be created. And here I offer some example prompts that could lead to misinformation. So please, for the sake of internet safety, don't go out of your way to generate misinformation, but these are typically the ways that misinformation can be generated using LLMs. First and foremost, the unintentional type, which is hallucination. If you ask large language model to formulate a piece of content, it could generate information with no veracity. And there's also, on the other hand, intentional form of generation, such as arbitrary misinformation generation, when you give a pretty broad prompt, such as generate a piece of misinformation, and in a certain domain, and this will just generate certain form of misleading information given a domain or a certain style. And in the more structured form of generation, we have intentional controllable generations, in which a LM user could input a misleading passage or sentence and control the level of a degree of new content that's generated to supplement the misleading content. Certain approaches are paraphrase generation, where a misleading passage could be rewritten or paraphrased to be more convincing and deceptive and to conceal the authorship. And there are also more open-ended generations given a piece of seed misleading content or a piece of truth that's meant to be distorted in the process. And so why should we care about this? So it turns out it's really difficult to discern LM-generated misinformation from human created misinformation. From the graph on the right, you can see the distribution of human written versus LM-generated content is virtually indistinguishable from one another. And this is a sign that it would be very difficult to classify. And indeed, look at the graph on the left, there's actually a very low success rate for human detection for many forms of misinformation generation. Fortunately, if you look at this bar graph, GPT, a large language model, could be leveraged as a detection mechanism and does typically outperform humans. The takeaway here is LM-generated deepfake is nearly indistinguishable from human-generated information, and human evaluation has a very low success rate at detecting this information. And we also need to look beyond just the textual modality, as misinformation is not just limited to text. Once we move away from the text modality, we can see that image, audio, and video formats are also popular modality for misinformation. Usually this will be captured underneath the umbrella of deepfakes, where synthetic media is created with a existing person in mind, and certain aspect of the video will be replaced with low veracity content. And this is especially of concern because generative multimodal model has now been popularized and can introduce more risk. For example, a generative model made by XAI, such as Grok, there's actually very little guardrails around this model. So certain images, disturbing images as this, can be generated with depiction of violence and also infringement on intellectual properties. Here we actually see a distribution of deepfakes on social media platforms, and obviously video sharing platforms such as YouTube is a popular and prevalent source of misinformation of the deepfake variety. So now I will cover the harms that are introduced by misinformation. While there's many harms, I will be covering two types of harms that are introduced by misinformation that are of particular concerns today. One is encroachment on civil liberty and integrity. The other is encroachment on personal safety and privacy. So many of you have heard the term fake news, which is a term popularized during the 2016 US election cycle. Fake news is obviously misinformation generated to mislead the audience. It accounted for 6% of the news consumption during the election cycle. And we actually see great disparity between the distribution of the fake news and consumption of fake news, where 1% of the users were exposed to over 80% of the fake news, whereas 0.1% of the user is responsible for sharing 80% of fake news. And this is concerning because it's concentrated amongst conservative voters, which contributed to deeper bipartisan divide. And 44% of American over the age of 18 has visited an untrustworthy article on an untrustworthy website during this time span. This impedes on civil liberty and civil integrity because many of the source of news could be traced to foreign interference, and it impedes people's clear decision-making process. On the other hand, let's look at a case that's been recently brought back to light, which is the Nth Room case on Telegram. Recently, the perpetrator of one of the biggest deepfake sextortion crime in Korea was arrested along with the CEO of Telegram. This case is related to dissemination of deepfake pornography, which especially targeted minors, and many young women in Korea actually removed themselves from social media presence because that was the key part of vulnerability that these perpetrators targeted. Their likeness were taken off social media and used to generate deepfake pornography, which led to extortion of these I guess social media users. And after 2 years of investigation, the perpetrator has finally been arrested. It took such a long time to lead to their arrest because Telegram actually offered a certain level of anonymity, and there is a lack of accountability for these distribution. And this is a case in which many people's personal safety and privacy were violated due to the advent of generative model that allowed these type of criminal content to be generated. Now, how can we combat misinformation using large language models? I have alluded to this a little bit earlier with the plot on misinformation detection using GPT. Here, I will backtrack a little bit and talk about how misinformation is detected prior to the advent of large language models. First, we use intrinsic evidence from the text itself to do detection and classification. Some of the techniques that were used are based on classic NLP techniques, which leverages linguistic features and uses frequency statistics such as that uses bag of words and frequency statistics methods. Many features that were used are stylistics, which from that standpoint, misinformation typically has a more limited vocabulary and has a more informal and sensational tone, and it uses more superlative and exaggerated swear words in its content. Misinformation typically is less complex and has less lexical diversity that can be measured with token type ratio. Misinformation also has certain psychological features that could be analyzed through sentiment analysis and linguistic inquiry and word count, and strongly correlated with the sentiment of being misleading, as the intention may suggest. Traditional machine learning models that were used for classifying misinformation are LSTM and CNN prior to the advent of transformers. Graph neural networks were also used for sentence level sentiment correlation for misinformation classification. There were also many BERT-based approach, one of which I'm going to highlight here is called fake BERT, which is BERT with a layer of convolution neural network superimposed on top for classification. There were also many generative and adversarial approach for classification, which does speak to some of the approaches today when synthetic data is generated to aid the classification of misinformation. And beyond intrinsic evidence, we can also look at extrinsic evidence, such as the social context and social network around the dissemination and the engagement of these information. Typically, social network engagement signals were also used as a way to identify misinformation. We could use user-to-user network, user content networks, and propagation trajectories to perform certain levels of classification using graph neural networks, mixture Markov model, and Markov random field. External knowledge is also helpful with knowledge racks and evidential text curated by domain knowledge expert. It actually offers a good way to classify and offer reasoning and root cause to certain decision. Fact checking is a human into loop method that's used to curate more supervised labels that would be able to feed back into certain classification frameworks. All of these external knowledge frameworks were definitely more manual but effective. Another concern that was needed during this time is to scale up these more manual interventions. Generalizability of these methods and procedures were very important because oftentimes fake news domain do shift over time, and a lot of work was done in forecasting the next distribution of fake news. And there were work on reducing supervision costs, and we can bootstrap on different modality and languages for low resource languages, and to offer stronger signals from all the available information on a piece of content. So fast forward to today. Even though a large language model can be bad at generating factual content, it can actually be a really good fact checker and used in the process detection. I broke it down into 3 types of roles that LLMs can play in the process of detecting misinformation. First, it can be used as a feature extractor, data generator, and analyst. An LLM can be out of the gate used as a fact checker because it's significant a priority knowledge and domain knowledge when it's trained on many examples. Its ability to perform zero-shot learning and reasoning capabilities make it very useful in detection and fact checking. Chain of thought and few-shot prompting could be used to improve this performance. It could also be used to generate more synthetic or misinformation data to aid in classification, almost in a similar generative adversarial paradigm as before. It could also be seen as an agent or tool user. Many fact-checking behavior would require searching for additional sources, so an LLM can be augmented to work with multiple modality and agentic function to perform fact-checking with sources, such as leveraging the capabilities of Google search. Google DeepMind actually roll out the SAFE framework, which is search augmented factuality evaluation, to perform hallucination and veracity check on content. Lastly, LLM can be used as a decision maker with reasoning capability. Large language model can out of the gate offer reasoning explanation for decisions and misinformation classification, whereas a traditional machine learning model has a harder time at offering exact explanation. An example of this is program guided fact checking, which decomposes complex claim into simpler subtasks, which can be solved easily, and this offers a good level explanation. Another technique that can be used is using LLMs to incorporate citation, which will enhance content transparency and verifiability, thereby actually confronting some of the IP issues when deploying a large language model, as it is trained on a very large corpora. However, large language model is not entirely foolproof. Here, I will highlight a few case studies in which a large language model actually had problems in misinformation detection. First and foremost, it's the feedback effect. Since a large portion of the internet contains misinformation, this misinformation will in turn pollute large language model. The saying goes, garbage in, garbage out. If the content that we used in the training corpus of the large language model is polluted with information with low veracity. This will actually reduce the large language model performance by 87% in this study. And another way that large language model, especially open source models, is vulnerable to misinformation is a form of attack called misinformation bias edit injection. A lot of open source model has mechanism for RLHF, which allow users to continuously tune and improve the model and edit certain responses to improve the model. This improvement mechanism could actually be exploited to inject more misinformation and bias into the system. And this was concern raising in the study because the performance score of the large language model actually improved with misinformation bias attack, showing that the model is not under stable equilibrium in the current state. And there's currently no good solution to prevent these type of injection attacks. And this is a issue because the safely alignment feature that's typically used for aligning large language model to human value is very fragile under these attacks. And this is a threat to the open source community because these models are publicly available and it's open to attacks as such. Also, large language models suffer from a phenomenon called the false negative problem. When a large language model is asked to judge the veracity of a piece of content or claim, it's predisposed and biased towards returning negative judgment, even though the content may or may not be true. And the bar chart from the above showed that there is such bias across LLMs provided by Mistral, ChatGPT, and the newest variant, GPT-4. There's also another challenge that large language models face, which is called catastrophic forgetting. When a model is large enough and holds long enough context and is continuously tuned with instruction tuning, it tends to forget information that's previously learned. And this phenomenon is observing large language models ranging from 1 billion to 7 billion parameters and is possibly linked to the phenomena of hallucination in large language models. And today there isn't a good way to mitigate this type of catastrophic forgetting in models. Now, how can we mitigate misinformation going forward after I've highlighted various form of detection strategy from both traditional ML and large language model and its possible failure modes? I would like to break down the possible recommendations with respect to the LLM development cycle. Certain strategies will be targeting the pre-processing stage, certain strategy will be targeting in the in-processing stage, where certain strategies will be used post hoc after model deployment. So I will first discuss some proactive techniques that are usually geared towards the pre-processing and in-processing steps of LLM development. One of the good ways to prevent misinformation spread using with the advent of large language model is to watermark synthetic AI-generated content with tamper-proof latent artifact that would clearly delineate synthetic data from human data. Another way that we could also prevent misinformation is through human value alignment, through both continuous tuning and reinforcement from human feedback for factuality and safety. Here I list a few examples of projects that have accomplished this task of human value alignment for safety. For safety, I would like to highlight Shield Gemma, which is a set of model that were provided by DeepMind that are instruction tuned on safety context and against a set of defined safety policy. And Llama Guard is similarly trained and tuned against a set of safety guidelines. There were also projects work that were targeted towards factually aligning large language models using RLHF, which augment the reward model of the alignment process with additional factual information, such as image captions and ground truth multiple choice options. And this was able to increase the veracity of the large language model without compromising its performance. Another technique that could be used to reduce misinformation is reader ensembling, which allow the labeling and detection of misinformation to be more robust. First, we can split up the context in which the veracity check is done against into chunks that formally represent different concepts. And we could run multiple rounds of evaluation against these contexts and use multiple vote response to formulate a more certain response. And obviously, since large language model is only as good as its training data, ablation of problematic training data could also prevent further generation of misinformation. And it actually does take a lot of effort to identify and ablate these information. In addition to pre-processing and post-processing techniques to prevent misinformation, we could also look at post hoc adjustments for eliminating misinformation and mitigating the process. First, we could zone in on detection and filtering, which is something we've discussed in length earlier. We could perform content level detection and filtering after a piece of content has been generated, and also prompt level protection, which would block misinformation attack before any piece of content has been generated. A way to also reduce misinformation is through proactive hallucination detection, which shout out to Arthur Shield. This is a capability of our product to be able to detect hallucinations that are generated from large language models. From the perspective of social media providers, it is important to downrank or remove generated content so it does not create further feedback loop and amplify these misinformation. Proactively, we could also combat misinformation by generating more persuasive anti-misinformation messages to debunk certain existing misinformation. LLMs can actually be a great tool here to rewrite debunking statements in response to existing misinformation, and it could very much reduce the overhead of this process. Another large part of reducing misinformation is creating accountability structure. A way to do so is to create proper attribution for misinformation to trace to the origin of a propaganda and conspiracy theories or malicious attacks, such as something similar to the nth room case, and hold the publisher accountable. We can also count on legislative changes to catch up to the current concern. For example, the Senate has recently passed the Defiance Act, which outlawed AI-generated sexually explicit content, whereby the victim of these deepfake crimes could hold the perpetrator against and could receive up to $150,000 in damage if the content has been properly attributed and the so perhaps I have painted a rather gloomy landscape with large language models advent. Today, we actually can celebrate a small victory in the space of content safety and in the reduction of misinformation. For example, the biggest generative model that's open source has been removed due to the fact that it's trained on child sexual abuse material. Stable Diffusion 1.5 was the biggest generative model on the market. Before its takedown, it has over 6 million downloads per month. Since it's been found to be used in various undressing services, such as to generate what experts term as NCII or deepfake pornography. And this is definitely a step towards the right direction to remove possible generators of unsafe material. And it might be worthwhile to investigate into removing other open source model that's trained on the Leon 5B dataset, which contains significant amount of child sexual abuse material. In conclusion, LLMs could be very useful in today's day and age, even though it can be a source of misinformation propagation. I hope that users of large language models can be vigilant and be conscious of the choices they make when generating content, and would stay mindful of the fact that certain content generated may or may not be truthful. And as I finish this presentation, I would like to highlight a few ways that you can get involved with removing misinformation or preventing misinformation spread in the age of large language models. First, you could participate in open source red teaming exercise, such as for large language model and generative AI safety. A project that I would like to highlight is the adversarial nibbler, which collects large set of examples and data which highlight the failure modes of text to image generation, whereby it collects seemingly benign text prompt, which would generate image outputs that may or may not be harmful to the end users. The goal is to generate content that from the get-go, from the prompt level, may look safe, but creates unsafe images. You could also get your hands dirty in labeling data. For example, this project called Detect Fake experiment that's hosted by MIT and Northwestern, in which you're able to decide whether a piece of image is generated or real. And there's also a plethora of competitions are hosted to refresh the state-of-the-art benchmark when it comes to misinformation detection and veracity. And yeah, I will now open the floor up for question. Okay, the first question that's posted is, how does missing information relate to misinformation? Missing information is the intentional or unintentional, I guess, intentional, unintentional omittance of certain information. You can think about this as a question of coverage, right? Like, if it's certain attackers want to deliberately mask certain information, and it might be worthwhile to delete certain information that needed to be masked, and this information will be eventually left out in, let's say, the language generation process. And it's more about, I guess, informational coverage, and you can think about this in the harm structure as like allocational harm instead of like, sorry, representational harm, and certain part of the knowledge base will not be represented. The second question is, how is Arthur addressing mitigating misinformation with Shield directly? Shield has the capability to protect against hallucination today. This is through active detection of hallucinated content, and obviously has safety mechanisms in which that you will either flag or block unsafe language, either from both the user and from the large language model. It also protects against injection attacks, which may or may not fall into the realm of asking to generate misinformation. Incoming question, how do you measure content veracity? That's a really good question. I guess there isn't a straightforward metric or evaluation technique to do so. A lot of veracity can be measured against a set of ground truth, either is human curated or I guess crowdsourced. It depends on this, I guess, the instantiation of your machine learning model, whether it's a binary classification problem or it's more of a text span problem. So any of this can be essentially boiled down to relevant NLP metrics. Okay. Do you think we're close to a future where disinformation spread by political actors can be accurately found and stopped? Good question. This is actually very difficult to answer since the process of misinformation generation and detection is very much like adversarial. I suppose that with the advancement of detection techniques, there will be more sophisticated counterattacks. So I guess this is always like a moving bar, and it may or may not be there may not be an absolute answer to this. Okay. Does the open source nature of large language models impede the development detection tools? This is also like a question I cannot give a yes and no answer to. While open source nature certain large language models make them vulnerable to attacks such as misinformation edit attacks. The fact that it's open source actually makes it, I guess, more adjustable and amenable, and there's a way to create certain red teaming exercises, which will ultimately improve the robustness of a model. Okay, since some models have a bias towards their own generation, would the best practice be not to use any hallucination detection for content created from its own model? That's a really good question. So it would be advisable to run hallucination detection on a few models and benchmark across the board to see which one has the best capability. It's very difficult to generalize overall, but from the assumption that a model can be biased towards its own distribution, yes, it might be helpful to compare across the board of a few models than just choosing one and sticking with it, since that they do have inherent bias and internal feedback. What does the future of the internet look like if AI-generated content increasingly populates the network, gradually exacerbating misinformation? How can we protect against it? I guess this is the question. Yeah, that's actually a really good question. I guess I can ask this question back to the audience since like we've all lived through the age of before the advent of generated content and a time that may or may not have more generated content. Can you like personally discern a difference in the type of content and the distribution? Do you find the content more engaging overall? There's all obvious ways of combating misinformation where a social media platform has to take proactive move to eliminate the dissemination of such information or reduce the feedback loop from a, I guess, ranking recommendation perspective. I guess eliminating the source would be easier than just detecting and removing it, everything. This is a long question, so I'm reading through it. So the gist of the question is, there's a type of misinformation attack whereby repeating misinformation multiple times can make it feel like it seems true based on like human bias. Um, and by reducing overflooding like the pool of information with misinformation there and thereby reducing the frequency of true content, the true content start to seem less true. And how can we counter this type of, I guess, attack? um Obviously by detection you were able to at least remove some of the misinformation from its source and reduce its propagation. This is definitely a question for social media platforms and designers of, uh, I guess, relevance and recommendation systems. How can we amplify content with higher veracity? Um, it could be through designing a better recommendation system that bias towards veracity than, I guess, virality. Just because misinformation typically are more engagement, like baiting, right? Clickbaits exist. So we might have to change the objective of recommendation system and how content is delivered to not bias towards the most obvious engagement signals. And this may or may not resolve this problem from a more, um, I guess, like from a deeper root cause style um, mitigation, I guess. Yeah, I think that's all the question. All right. Thank you everyone for tuning in, and I hope you have a great rest of the week.